We all take our car brakes for granted, right? You press the pedal, the car stops. But what if the part that does the actual stopping just falls off the assembly? It sounds like a cartoon, but it's a very real and very dangerous possibility.
It's a terrifying thought, and it really shifts the focus. We always think about the brake pad material itself, the part that creates the friction. But the real story, the one that determines safety, is how that material is held in place.
Exactly. And that brings us to the unsung hero of the brake system, the backing plate. It seems like just a simple piece of steel, but it's actually a multitasking marvel. It's the structural support, it acts as a heat sink to prevent brake fade, and it even has built-in features to dampen noise.
Right. It's the skeleton and the radiator all in one. Without that rigid heat-dissipating plate, the friction material would just crumble or overheat under pressure. And many have that little wear indicator tab that makes that awful screeching noise, which is basically your car screaming, "Hey, change my brakes."
So, for the longest time, the industry standard was to just use a strong adhesive to glue the friction material onto that backing plate. But that method has a pretty serious Achilles heel.
A huge one. That glue can break down. Think about everything your brakes are exposed to: extreme heat from stopping, moisture from rain and puddles, and road salt in the winter. All of those things degrade the adhesive over time,
which can lead to the friction material literally peeling away from the backing plate. That's a catastrophic failure.
It's a complete loss of braking power on that wheel. To solve this, the industry developed mechanical retention systems. Instead of relying on glue, the backing plate itself has hundreds of tiny steel hooks or teeth built into its surface. When the friction material is molded, it flows into and around these hooks.
So it's physically locked in place like concrete with rebar inside. The bond isn't chemical, it's mechanical.
Precisely. This mechanical lock is what makes all the difference. It virtually eliminates the risk of the pad material separating from the plate, which is, as you said, the most critical safety factor. This is especially important for trucks or anyone towing a trailer.
That makes sense. And you mentioned it's especially relevant for electric vehicles, which I found surprising. Don't they use their brakes less because of regenerative braking?
They do, and that's the problem. Because the friction brakes are used less often, they don't get as hot, and moisture can sit between the pad and the plate for longer. With just an adhesive bond, that creates a perfect environment for rust and corrosion to form, weakening the bond from the inside out. A mechanical lock doesn't care about moisture.
So this is a real aha moment for me. If I'm a regular car owner needing new brakes, how do I know if I'm getting a pad with this superior mechanical system? Is it just a matter of buying the most expensive option?
That's a great question. Price can be an indicator, since it's a more advanced manufacturing process, but it's not a guarantee. The best way is to look at the product details. Reputable brands will often advertise it using terms like NRS, mechanically attached, or showing images of a hooked backing plate. It's about looking past the marketing slogans and checking the actual specs.
I see. So it's not just a premium feature or an upgrade. It's really a fundamental safety technology that ensures the brake pad works as intended, especially under tough conditions.
Absolutely. And when you think about the future with heavier EVs and even autonomous vehicles, that level of guaranteed reliability becomes non-negotiable. It proves that a strong mechanical bond is the key to safer, more durable brake pads.
So, to wrap this up, what are the most important things for our listeners to remember?
I'd say there are 4 key points. First, the backing plate is the structural foundation of your brake pad. Second, old school adhesives can fail, but mechanical retention systems physically lock the friction material in place. Third, this mechanical lock is critical for preventing brake failure, especially in EVs or high-load situations. And finally, when you're buying new pads, actively look for proof of a mechanical retention system. It's one of the most important safety decisions you can make for your car.